Okay, so we're going to start off with the product sums formulas. And so these are the four, 39 through 42 we'll start with. And our first problem is to use the product to sums formula to rewrite the product as a sum or difference. So we're starting off as a product and we're changing it to a sum. So looking at our options over here, for that example, which one do you think we need to use? 42. Now I do know, because I looked at the reference sheet, they sent out a new one. Only 41 is like 39, 40, and 41 are on the reference sheet for the challenge exam. So if you get one like 42 where it's cosine times sine, just switch the order and use 41. It's not really necessary for there to be a sine times a cosine and a cosine times sine. But we're just going to go ahead and use 42. So what we'll do for this problem is take 2 theta and put it in for u, and take 7 theta and put it in for v. All right, so we'll have the 1/2 in the front, and then we're multiplying it by the sine of those two angles added, then minus the sine of those two angles subtracted. Okay. So now we'll go ahead and add 2 theta and 7 theta. Okay. And then we'll subtract 2 theta and 7 theta. And on a multiple choice test, this would never be a choice where it's the sine of negative 5 theta or the cosine of negative 5 theta. So do you guys remember if sine is even or odd? Anybody remember? It's on the other side of your identity sheet. What is the sine of negative u? What does that say? Negative sine of u. So sine is an odd function. So the sine of negative 5 theta is equal to the negative sine of 5 theta. So what's going to happen to that minus? It's going to change to a plus. And that's all we can do. So we can't add sine of 9 theta and sine of 5 theta. They're not like terms. We can't add them. We can't add the 9 theta and the 5 theta. We can't add angles when we're dealing with sines and cosines. So that's it. That's all we can do. That's the answer. All right, any questions on that one? Not too terrible. All right, let's look at the sum to product. So this is the opposite. You're going to start off with either a sum or a difference, and you're going to change it to a product. So on example 2, we have cosine of 4x minus cosine of x. Again, we cannot subtract and get cosine of negative 2x. Cosine and sine do not work that way. So if we want to change this, we're going to have to use one of the formulas. So that one was cosine minus cosine, so we're going to use number 46. So in the place of u, we're going to put 4x, and in the place of v, we're going to put 6x. All right, so I'm going to go ahead and add and then divide by 2. So when I add, I'm going to get 10x, 10x, and then dividing that by 2 is going to be 5x. All right, and then I will subtract and get negative 2x and divide that by 2, and it's going to be negative x. Okay, and then we have the same situation we were just talking about. For sine of negative x, that's going to be the same as the negative sine of x. Okay, and then we're multiplying these together. So what I can do is multiply the coefficients together. So I have negative 2 times negative 1. That's going to be 2. Now can I multiply those signs together and get sine squared? I cannot, because this one is sine of 5x and this one is sine of x. So we just leave them. And that is it. All right, any questions on that? Okay, we're going to do a couple more. These are going to involve actual angles that have values, not just variables. And then we are going to have to go to like a hand trick or something to figure out cosines and sines. But before we do this one, is pi over 12 special? So 12 in the denominator when it's reduced is not special. Can I just add and get the cosine of 6 pi over 12? No, angles don't work that way. We can't do that. What we can do is go up here and use number 45 and put in pi over 12 for u and 5 pi over 12 for v. Okay. So if I add pi over 12 and 5 pi over 12, what do I get? 6 pi over 12. And what does that reduce to? Pi over 2. Now I still need to divide that by 2, but I'm going to wait and do that in the next step. All right, and then for these, I'm going to subtract. So when I subtract, I get negative 4 pi over 12. What is that going to reduce to? Negative pi over 3. And then I'm going to divide that by 2. Okay. So I need to divide these fractions by 2. So dividing by 2 and taking half mean exactly the same thing. So what's half of a half? A fourth, good. What's half of a sixth? What's half of a third? A sixth. All right, so that's cosine of negative pi over 6. All right, is cosine even or odd? Cosine's even. So the cosine of negative pi over 6 is exactly the same as cosine of pi over 6. So I would just drop that negative off. All right, and then after this, it's just using the hand trick or whatever you guys do to figure out the cosine of pi over 4 and the cosine of pi over 6. So you guys finish that off for me, please. Or just fill in those parentheses. And some people, to multiply fractions, they need everything to be a fraction. So if you want to write that 2 as 2 over 1, you can. You don't have to. It's fine. Now, I like to cross-reduce. Do you guys like to cross-reduce before you multiply? Okay, I just think it makes it easier, especially if you're doing it in your head without a calculator. So if I have a 2 in the numerator multiplied by something with a 2 in the denominator, I know they're going to cancel out and become 1. So I can just take them out of the picture and then multiply across the numerator and across the denominator. So that should be the answer, the exact value of cosine of pi over 12 plus cosine of 5 pi over 12. All right, so what I want you guys to do for example 4 is get it set up on your own. So look at these 4 formulas in the example 4 and figure out what U and V are, and then plug it in and then start working. And get as far as you think you can on your own, and then I'll pick back up. All right, so that's just using the formula to replace U and V with 195 degrees and 105 degrees. Then we can add and divide by 2. So we add, we get 300 divided by 2, 150 degrees. Subtract, get 90 divided by 2 and get 45 degrees. Are these special? 150 degrees and 45 degrees? Yes. So I know you guys are a little better at picking out special angles with radians, but with degrees, your super special angles are 30, 45, and 60. And then if you have any angle that is a multiple of one of those, it is also special. Whoops. All right. So we have to figure out, like 150 is definitely a multiple of one of them. So sometimes, like anything that is a multiple of 60 is also a multiple of 30. So sometimes you have to do multiple steps to figure out the reference angle. So if you would, like, I think you should on your own figure out that 30 is the only one of these that go evenly into 150. But that's okay. If you can't, think about where 150 degrees is. It's in quadrant 2. And then think about the angle between 150 degrees and the x-axis. What is that angle? 30 degrees. So that means whenever we want to find the sine, cosine, tangent of 150 degrees, we use the 30-degree finger. All right, so in quadrant 2, would the sine be positive or negative? Positive. And then we use our 30-degree finger, and it's the square root of the bottom fingers over 2, so that's 1 over 2. All right, and then for 45 degrees, we use the 45-degree finger. It's the square root of the top fingers over 2. Okay. And then we're to the same situation where we were last time. We can cancel those out. Our answer at this time is just going to be the square root of 2 over 2. Sorry, I'm in a weird mood today. All right, so for example 5, we're going to use the power reducing formulas. Now, if you guys look at your sheet, these have a star by them, which the star means that they are not on the challenge exam reference sheet. However, I just got a new copy of the reference sheet and they put them on there, and I'm so happy. Like, the teachers complained about it for like 3 years, and so they finally put them on there because every year that I've seen, they have put a question on there that you need them to do it. You can do it using other formulas, but it takes forever. These formulas really help you do it. So we complained enough that we got it on there. So that makes me very happy. So you can mark out that star because it's definitely going to be on there. All right, so what we're going to do on example 5 is use the power reducing formulas to rewrite the expression in terms of first power of the cosine. Now, you can only use the power reducing formulas for squares. Sine squared, cosine squared. There is one for tangent squared, but I don't think we're going to need it. So how can I rewrite sine to the 4th? We're going to do sine squared times sine squared. All right, so now I can use the power reducing formula for sine squared and then just multiply it by itself again. So if we want to reduce down sine squared of x, we're going to do 1 minus cosine of 2x over 2. And like I said, we would have to do that twice to make it work for this problem. And from here, for a lot of steps, it's straight algebra. Now, even though there's a cosine thrown in there, we're using it in an algebraic way, okay? So now I'm going to multiply these together. Let's do the denominator first since it's easy. What are we going to get on the denominator? 4. In the numerators, you have options. So since we're multiplying something by itself, we can use the shortcut for squaring a binomial if you want to, or we can distribute the 1 and then distribute the negative cosine of 2x. Which one do you guys want to do? Shortcut or distribute? Shortcut? Okay, so the shortcut, we're going to, because we're basically doing 1 minus cosine of 2x squared. So we would square the 1, multiply these together and multiply by 2. Now the 2 is multiplied in front. Right? And then square the second one. So when we square it, we're going to get cosine squared of 2x. That angle is not changing in any of that process of squaring it. Now, have we done what we were asked to do? Is this all first power of cosine? No, we still have a second power. So we have more to do, but it's okay. We can do it. So what I'm going to do is break apart this fraction. So I'm going to take each term and divide it by 4. So we'll have 1/4. And then when we do negative 2 divided by 4, that's going to be negative 1/2. And then 1/4 cosine squared of 2x. All right, so the first part of this is not the problem. We're in good shape with those, so I'm just going to bring it that part straight down. And the only part that needs to be changed is the cosine squared of 2x. All right, so we're going to use number 34. What are we going to put in the place of u? We have to put in 2x, right? So it's going to be 1 plus cosine. And then it's going to be 2 times 2x, because the formula is 2u. So what's that going to be? 4x over 2. All right, that's a lot of steps. There's a lot of places to make a mistake. So we're going to practice these a lot. So get ready. It's happening. All right, so here we go. And I debated about, at this point, like the most logical way to do this, or what would make the most sense to you. And I don't really know what would. So what I'm going to do is what makes sense to me, so hopefully it'll all make sense. Go ahead, and I have that 2 on the bottom of the fraction. I'm going to pull it out. But when I pull it out of the parentheses, it's 1/2 because the 2 is on the bottom. Does that make sense? That's kind of weird. But and then what you're left with is what's on the numerator. Okay, so we're getting really close. So that's going to be 1/8. Now, at this point in a multiple choice test, you maybe could figure it out like by looking at the choices. But let's finish it up by distributing that 1/8. All right, and then the only thing we have left to do is an arithmetic part. Oh, what was that? Shoot. I don't know how to get rid of that. Is combine those fractions. So we need to add 1/8 and 1/4. So how many eighths is 1/4? 2/8, right? So 1/4 is 2/8. So we're going to add 2/8 and 1/8 and get 3/8. And this is the crazy answer that we have. Only first power cosine. No, it's a lot of work. But it was a lot harder to do with not using that formula, believe me. Okay, so you guys have, I don't even know. The thing is wrong on the board. I think you might have some time in here to work on this. Now tomorrow, most of you are going to be in the boot camp, so we just work on it.